Hey guys, so in this video I'm going over Math 2 Standard Quiz 1 for Unit 1. The first one we are looking at the domain, range, max or min, x-intercepts, increasing or decreasing, y-intercept, function or not. So before we start, I wanted to go over the steps to find your x-intercepts if you cannot look at your calculator under the table, or if you are not given a graph like we are in 1 and 2. So the first step is to type your function into your y equals. Step 2 is to push graph. Step 3 is to hit second trace to get that blue or yellow word calc, because you're going to calculate something on the graph. Step 4 is to select number 2 under that calc to find your zeros. Step 5 is to set your left and right bounds. Once you have set your right bound, it's going to ask you for a guess, and you're going to hit enter, and then you're going to hit enter again to get your x-intercepts. So that's why step 6, you're hitting enter twice. So let's look at number 1. Number 1, we do not have to do those steps because we're given a graph. Now, on this graph, there is no set interval, and it is not a word problem, so our domain is always going to be that negative infinity to positive infinity, meaning from the vertex, we're going to go to the left forever and to the right forever. So at the top where it says domain and range, we're going negative infinity to positive infinity. For a range, however, is a little bit more difficult. We are looking bottom to top. Our bottom of our graph is right here. Our smallest y value is approximately negative 25. So our smallest y value involved is negative 25. We do have a dot or a point there, so we're going to use a bracket. And then for our y values, they're going to keep going up forever and ever and ever. So our biggest y value involved is positive infinity. Now let's erase everything we wrote on our graph. And let's look at our min or max. Because we can pinpoint our smallest point on our graph, we have a min. We cannot pinpoint our highest point because it keeps on going up forever and ever and ever. Now, our minimum or our min is approximately, so these are counting by twos, so 2, 4, 6, 8, 10. That is how I know it's counting by twos. And it's in between 2 and 4, so it's approximately 3. And then down to our approximately negative 25. Now, our x-intercepts, again, these are counting by twos on our x-axis. So starting at the origin, going over 2. So 2, 0 as our first one. Our next x-intercept is right here. So we're going to go over 8 and 0 up or down. So we have 8, 0. So let's erase everything and look at our increase and decrease. So our increase and decrease, we're going to split the graph at our axis of symmetry or line of symmetry and determine what interval it's increasing versus decreasing. So on the left side, reading left to right, it is going down. So for decrease, we're going to go negative infinity, our smallest x value on the left side of our graph, to our biggest x value on the left side of our graph. So it's going to be where our graph changes directions going up versus down. Our x value there is 3. Now, on our right side, smallest x value is going to be at 3. And we're increasing, we're going up all the way to positive infinity. So our biggest x value involved for our increase interval is positive infinity. And we can erase all of this so we can look at our y-intercept. Our y-intercept is this little point here. We're going to go 0 left or right, so that's going to be our x value, and then we're going to go down, remembering this counts by 2, so negative 10, negative 12, negative 14, negative 16. And then we're asked, is it a function? So how we check to see if it's a function or not is the pencil test, the vertical line test. So anywhere that we draw a vertical line, and no, these are not straight, but just imagine if they're straight. If all of these were straight lines, does the graph only intersect these lines once? The answer is yes. So if they only intersect the vertical lines once, the answer is yes. So I'll give you a second to look over this, or you can pause the video. Remember, if you have any questions you need to ask while you're in class, come to comment time or email me, and I will answer your questions. So let's look at number 2. Number 2, again, we're given a graph, so we're going to look at this graph. In this case, it is not a typical quadratic that we are used to. So we have to look at this a little bit more carefully. We're going to see that our smallest x value is at 1, 2, 3, 4, 5, 6, 7, so negative 7. There is a point there, so we have including negative 7 as our smallest x value. And then our graph is going to keep going to the right forever and ever and ever. So our biggest x value is positive infinity. Now for our y values. Our smallest y value is in that blue that I'm drawing right now. The smallest is negative 1, negative 2, negative 3. And there is a point at negative 3. And then it's going to keep on going up slowly forever and ever and ever. So we're going to go to positive infinity. I'm going to erase it for our domain and range so we can look at our min or max. So looking at this graph, we can see that we can pinpoint our smallest point, but we cannot pinpoint our largest point because this graph is going to keep going forever and ever and ever up slowly. So we're going to have a min, and that min is going to be at negative 7, and it's going to be negative 3. So negative 7, negative 3. So now we can erase that, and we can look at our x-intercepts. Our x-intercept. So the only time that the graph intersects the x-axis is at 2, 0. Now looking at increase and decrease, starting from our left side going to our right, is it increasing or decreasing? It's increasing. So we have our smallest x value at negative 7. And we're going to the right forever, so positive infinity. Now decrease. Is there any point in this graph that it is decreasing, reading it from left to right? No. So we can put none for decrease. Now our y-intercept. Our y-intercept is right here, which is approximately 0.5. As long as you gave me something lower than 1, I would have counted this correct. Now, if you were given a graphing calculator and no graph to look at, then you should be giving me exact decimals. But because we were given a graph and we had to estimate, 0.5 is perfectly fine, and that should be at negative 0.5. And then we're asked, is it a function or not? So if we draw a bunch of random vertical lines, or if we dragged our pencil across it, any of the vertical lines, does the graph intersect it more than once? No. So our equation or our graph is a function. All right, so number 3. Number 3, we have to graph. Either you can use Desmos for practice, or you can use a graphing calculator. But you're going to go to your graphing calculator, you're going to go to y equals, and type in that equation. How do you get absolute value bars? You go to math, and then you go to number. So absolute value bars, go to math button, and number, and arrow over to number, and select the very first one. Hit x plus 2. You're going to arrow over to get out of your absolute value bars and subtract 1. And that gives you your graph. To graph this, I would go to second graph to get to your table. Your table is going to look something like this. You're going to have x values, y values, and you're going to have negative 2, 1, negative 1, negative 1, 0, 0, 1, and you can stop there. Remembering that you have to have at least 3 points when you're graphing. I made a mistake. So the whole table looks like this. Negative 5, 2, negative 4, 1, negative 3, 0, negative 2, negative 1, negative 1, 0, 0, 1, and 1, 2. So what I need you to do is look at your y values and see where it changes direction. So in between 2 and 1, it's going down. In between 1 and 0, it's going down. In between 0 and 1, or 0 and negative 1, it's going down. In between negative 1 and 0, it's going up. So right in between these two is where it changes direction. So I need the 3 points around this part to graph. So you can either select negative 3, 0, negative 2, negative 1, or negative 1, 0. Or you could select negative 2, negative 1, negative 1, 0, and 0, 1. I don't care which one you choose, but you need 3 of them. So let's select the green one. I have negative 3, 0 to plot, negative 2, negative 1 to plot, and negative 1, 0 to plot. So let's go on the graph. Negative 3, 0 is here. Negative 2, negative 1. And negative 1, 0. So it kind of looks like a V going on. So our V is going to look, or our graph is going to look something like this. So we got to determine our domain, range, max or min, x-intercept, intercept, or increase, decrease, y-intercepts, and function or not. So for our domain, we're going to go to the right forever. We're also going to the left forever. So smallest x value involved is negative infinity to positive infinity. Then our y values. Our smallest y value is at -1. There is a point there, so it is included. And then we're going to go up forever. So we have a greatest y value of positive infinity. Then we have a max or a min. Well, we can pinpoint our smallest point, and that smallest point is located at -2, -1. So for x-intercepts, x-intercept number 1, x-intercept number 2. Those locations are at -3, 0, and -1, 0. And that's parentheses and parentheses. So we've got to divide our graph out so we can determine what the intervals are for the increase and decrease. So this is where we will divide our graph. It is where a vertex is, and it changes direction. So on the left side, reading left to right, it is decreasing. So in our left side of our graph, our smallest x value involved is negative infinity, and our biggest x value involved is at our vertex, which is at -2, and it is included. Now our right side, smallest x value on our right side, which is increasing because it's going up, reading left to right, is at -2. And we're going to the right forever, so we're going to positive infinity for our biggest x value. Now, our y-intercept. We could look at our graph and see that it's going to be at 0, 1, or we can look at our table that we created. Our table, where our y-intercept is when x is 0, y is a number. So we're looking at 0, 1. Then we're asked, is it a function or not? If you want to, or if you can erase all of this extra stuff and look at your graph. If you drew random vertical lines through it, or up and down lines through it, does the graph intersect these lines more than once? No, so it is a function. So those are our key features that we had to identify. Now we're working on 4 through 7, which talks about the transformations, which we went over in the activity that we did Monday and lesson 4 that we did Tuesday. So for number 4, we are looking at what is on the outside. So if it is smaller than 1, it is going to be a compression or compress. Then on the inside, we have -5. It's going to be the opposite. So if we just took it as is and it wasn't opposite, it would be left 5. But because it's opposite, it's going to be right 5. Then we have the outside to look at. If we're on the outside, we're affecting the y's. So we're going to be either going up or down. We are obedient to the sign, so we're going to be going down 5. And that would be the transformation for number 4. In the directions, it also asks for you to state the parent function. The parent function is y equals x squared. The reason why I know that is because we have a squared involved. Now let's look at number 5. Number 5, if you want to go ahead and do the parent function, you can. Parent function is y equals square root of x. So this is what's helping me determine what is on the inside versus the outside. This -4. The negative is telling me that we are going to reflect over x-axis. The 4 individually is telling us it's going to be stretched because it is above 1 or greater than 1. On the inside, we're looking at +5. We're going to do the opposite. So it's saying positive, meaning right, but we're going to do the opposite, so we're going to go left 5. And then we have +2 on the outside. Outside affects the y's. It's positive, so we're going to go up. And we're going to be obedient to the sign. So there's the transformation for number 5. Number 6, the parent function is y equals absolute value bar x. The outside is telling me that it is above 1, so it's going to be a stretch again. There is no negative, so we're not reflecting. We're looking on the inside with the x. We have +3, doing the opposite of that sign, so we're going to go left 3. And then we have subtract 2 or -2 outside. Outside is going to affect the y, so we're going to be going down 2. So that would be the transformation for 6. Now 7 for some reason is down here. I'm going to actually rewrite it just so it looks a little bit better. We have y equals -2 over 5 cube root x minus 4 plus 1. So our negative tells us that we're going to reflect over the x-axis. Our 2 over 5 is less than 1, so we know that we're going to compress. Our -4 on the inside is telling us to go right 4. Again, remember, opposite of the sign. And then lastly, our outside tells us +1 or up 1. Remembering we are obedient to the sign if we're on the outside. And then our parent function is y equals cube root of x. So that is your quiz review. Remember, if you have questions, please email me and I can get back to you as soon as I can.